Today we're going to begin Chapter 7 on estimating parameters using confidence intervals. Okay, we see confidence intervals all around us, so I just wanted to show a couple quick places that these appear and just talk to you a little bit about those. Okay, so this is just an example. We're in the midst of this presidential election, the 2020 presidential election. So there's all kinds of different polls that are tracking the participation as far as the voter preference between Biden and Trump. And so you can see one here that's showing the polls. So with confidence intervals, we have something called a best point estimate. Typically, for each of these polls, what you're seeing reported is the best point estimate. It's the single value that that poll is indicating is the actual population value for whatever they're trying to predict here. But behind the scenes within each of these best point estimates is an actual interval around that. And so when we'll be saying that we're like 90 or 95% confident, and basically we're saying that we're confident that that level of confidence that confidence interval actually contains the true population parameter. So the whole point of these confidence intervals is that we're trying to estimate some unknown quantity about the population. So we can't get information from every single person in the population. So we'll do this through sampling and looking at the samples and constructing these interval estimates so that that'll give us an idea of what the true value is with that. So one example here is this with like I said with the presidential election, governor elections, all of that. If we look at this one here, you can see a lot of different scenarios that's being looked at through polling. One thing that I want you to start becoming more aware of is this information that's going to be printed at the bottom of most polls. I will say some polls are not good about providing this information, but here it says the survey was of 937 likely voters. So that kind of tells us who participated, the size of the sample. It also tells us the dates of the sample, and then our what we'll call our margin of error. So it has a 3.3 percentage point margin of error. We'll talk more about that later, but I do want you to start when you see these polls looking for this information because it is lurking behind the scenes. So it's never a case of us just saying it is 51% or it is 42.4%. It's actually that with that margin of error built around it. So here's some others. So it's not always just an election year that we see polls. Sometimes the polls are taken to give us a snapshot of people's opinions about other social issues. Justice Ginsburg passed away recently, and there's been some controversy about whether that seat should be filled on the Supreme Court or not. And so polls that will give us people's opinions about things of that nature will are also valuable. And so again, what you're seeing posted here are best point estimates of how people feel about it. But there is that underlying confidence interval that is built around that. And it is a little bit harder sometimes to find that margin of error being published. It does exist, it just may not be as readily available for that. So these are just again some quick examples of different polls that are around us. The last one here has some other social issues. Okay, so this one again is kind of talking about the seats on the Supreme Court, Biden with his lead over Trump, and then lots of other different issues. And some may not be as obvious, like here, the United States Postal Service should be run like a public service, not a business. So, there's different things that people are being polled about all the time, not just in an election year. And so those are just things that we kind of get the pulse of America, or not just America, but anywhere through these polls that are generated. Okay, so it doesn't have to be a poll that you're going to use a confidence interval. I just think that we see those a lot, and so I wanted to give you that idea. That's kind of what we're going to be working with in this chapter here. Okay, so there's three formats that you may see a confidence interval presented to you in, and those three are listed here. So we have the p hat, which is your sample proportion, and the capital E is your margin of error. So I prefer this first one, but you may very well see it as either of these other two as well, especially in professional journals. So we said the p hat is your sample proportion, and it's also that best point estimate that's being presented by the media in a lot of cases. So here it says a recent Washington Post ABC poll reported that 57% of Americans say that replacement for Justice Ruth Bader Ginsburg should be left to the winner of the presidential election. So this is that value that's being reported, and so that's our p hat. That's our best point estimate. Or if you were forced to give one single value, that would be the value that would be most representative of that. So you're going to also see here it says their margin of error is plus or minus 3.5 percentage points. So that's going to be our margin of error, or our E. So if we go to write these different formats, the first format we're going to substitute for the p hat. So that's going to be 0.57 because we want to convert these to percentages, to decimals in most cases, unless it specifies to leave it as a percentage. So I have excuse me, 0.57 minus 0.035. We're going to keep that p in the middle, and then we're going to have 0.57 plus 0.035. So we're given the p hat and we're given the margin of error. So we're going to make a substitution for the lower limit. We're going to make a substitution here on the upper limit, and we're going to leave the p in the middle for this particular format. So when I do this calculation, I get 0.535 and 0.605. So basically with this margin of error, even though 57% is what's being reported, we could realistically expect anything between about 53.5% to 60.5% as far as the range here with that. So for the second format that you might see these confidence intervals listed, sometimes we don't go ahead and find the upper and lower limits. We just simply report it as p hat, which is 0.57, plus or minus the margin of error, which is 0.035. So the advantage on the first one is that we can kind of see the lower limit and the upper limit and get an idea of the actual values. The value of the second one is that with this one, you can clearly see what the p hat is and what the margin of error is. And then the third one is just a little bit simpler way of writing this first format here. You still have the 0.535. You just put a comma and then the 0.605. So it's just kind of interval notation showing that it's anything between this value and this value. One reason I don't like this as much is it's not clear what's being estimated. In this first section, we're going to be talking about proportions. So this is going to be a P, but as we move on and talk about mean, variance, standard deviation, and so forth, this is going to be different other parameters. So just keep that in mind. Okay, so here's one in a recent internet poll of 2,000 registered voters, 44% said that they approved of President Trump's job as president, while 56% disapproved of the job he was doing as president. This poll has a plus or minus 3% margin of error. So I'm asking for you to pause the video here and construct the confidence intervals in all three formats for those that approve of the job President Trump is doing as president. Okay, so for one of the formats, we would do our p hat, which is the 44%. That's our p hat. Here's our margin of error, so this is our E. So we're going to have p hat minus the margin of error, keep the p in the middle, and we'll have p hat plus the margin of error. So this is going to be 0.41 and this is going to be 0.47. So basically what we're saying is even though 44% is what's being reported, and as we go, we'll learn that there's going to be like a 90% confidence level or 95% and so forth. So those, just say we're about 90% confident that this interval does contain the value that we're looking for, which is the percent that approve of President Trump. So it could be anywhere from 41% to 47%. We're just reporting it as the 44%. So this would be one format. The other format is taking that P out and just writing it like this. And then the third format is the 0.44 plus or minus 0.03. And there's nothing special about which one is format 1, format 2, or format 3. You just need to be familiar with all three of them and be able to work in between, back and forth between the three, depending on which one you see. Okay, second question here. Is it possible, based upon this sample, for a majority of Americans to approve the job President Trump is doing as president? So the interval that we just came up with was this. Okay, so majority is going to mean more than 50%. Okay, so to have a majority, it's got to be more than 50%. So if we look at this interval is clearly well below a 50% level here. Okay, so it's captured well below that, and therefore it would not be possible, based upon this particular sample, for a majority of Americans to approve of the job President Trump was doing. Okay, let's say, for example, if the interval had been something like 0.47 to 0.54. Okay, so if we had something like this, then the 50% would have been in here. So we would say that it was possible for a majority. So even though it might have been a value that was reported less than 50%, it would still have been a situation where it could have gone above 50% based on our interval, and therefore it would have been possible that a majority actually approved of the job President Trump was doing. Okay, so that was kind of just an introduction to let you know that confidence intervals are out there. We use them all the time, and we're going to now start getting into the technical side of it all. So a couple of definitions here and concepts that we'll be talking about. One is the best point estimate. For some reason, this is a highly missed question when it asks for the best point estimate, and it's the easiest question you're going to have the whole semester. The best point estimate is simply the p hat. And when we look at the next section, it'll be the x bar, but for now it's just the p hat. P hat is the best point estimate of the population proportion. So if you're asked to give the best point estimate, you literally just give the value for p hat and you've answered the question. Okay, the confidence interval, we use a sample proportion and construct the confidence interval estimate of the true value of the population proportion. So the population proportion is what we're trying to estimate, and through sampling and sample proportions, we're going to construct these intervals that attempt to estimate what that population proportion would actually be. So there's really no way of knowing what the actual proportion of the population of the United States is that truly supports President Trump. So that's something that in the previous example, we were trying to estimate that through these confidence intervals. And the last thing that we're going to look at in this section is sample size, because you want to know what size sample in order to have a certain level of confidence in your surveys. Okay, so the point estimate's a single value used to estimate a population parameter, and in this case, it's p hat. So here, if I had an example, a recent poll indicated that 52% of North Carolinians support Roy Cooper for governor. So our p hat in this case is simply the 52%. Typically, we work with proportions and not percent. So I would say you're going to be, in most cases, converting your percent to a decimal to give your answer. Okay, so in this section, section 7.1, we're going to be talking about proportions, and the best point estimate for the population proportion is the sample proportion, which is p hat. In section 7.2, we're going to talk about means, and the best point estimate for the population mean is the sample mean. And this goes back to those unbiased estimators. If you remember, p hat was an unbiased estimator that targeted p. X bar is an unbiased estimator that targets mu. Okay, so a Gallup poll was taken in which 1,487 adults were surveyed, and 43% of them said that they have a Facebook page. Based on that result, find the best point estimate of the proportion of all adults who have a Facebook page. Okay, so based on this sample, we want to give our best point estimate of the proportion of all adults out there that have a Facebook page. Okay, so this was pretty simple. The best point estimate is p hat. P hat is our sample proportion. So our sample proportion is 43%. So this would be my best point estimate. Okay, so moving on to what we really want to focus on, and that is our confidence interval. Sometimes it's called an interval estimate. It's a range or an interval of values that's used to estimate the true value of the population parameter. Sometimes you'll see it abbreviated as a C confidence. So I want to take a minute to look at this. This is a simulation of a confidence interval. Basically what happens is we're trying to estimate some kind of population parameter. For instance, an example of that might be what is the true population death rate of COVID-19. We know that we've all been trying to find this out, and there's different samples and different studies that come out that say different things. So basically, there is some given death rate of COVID. We don't know what it is, and so that's what we're trying to estimate. So that's going to be represented by this vertical line here. Each one of these little line segments here represents a different confidence interval. If we're talking about a 99% confidence interval, then what that's telling me is that 99% of the time, those confidence intervals are going to contain this value that we're trying to estimate. So those are the longer lines, the ones that go from the blue end to the blue end. The longer ones are the 99% because in order to have a higher confidence level, our interval has to be larger to accommodate that. So looking at these, if you notice, the only ones that actually miss this value they're trying to capture here, there's one down here that where it turned white, this interval, and then this interval here. So those two did not actually contain the value that we were trying to estimate, but all the rest did. Some may have barely contained it, and some it may have been right in the center of the confidence interval. And that's the thing, when you're given a confidence interval, you don't know that that value you're trying to estimate is in the center. It could easily be on one end or the other of that interval that you've been given. So if we drop down to a 95% confidence interval, that's the yellow line. So you can see that those lines are shorter because it's a smaller level of confidence. So in order to have a larger confidence level, you're going to have a larger interval. A smaller confidence level, you're going to have a smaller interval. You also notice that there are more of the intervals that miss this and do not actually capture the value that we're trying to estimate. So we've got one here, 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 and also here that don't capture that value we're trying to estimate. So, so the higher the confidence level, the more of the intervals it's going to actually capture the value that we're looking for, but the larger the interval that we're going to have as well. So that just kind of gives you a visual of what the confidence interval, how it works, and kind of what it's doing as possible as well. Okay, so a confidence level is going to be the probability of 1 minus alpha. So in this case, your confidence level is either going to be, your common ones are 90%, 95%, and 99%. So sometimes if you're talking about some type of social issue and people's opinions, like 90 and 95% are good enough. You're talking about testing some kind of medicine that could have potential life or death effects from it, then 99% or even potentially higher than that might be necessary. So your level of confidence is in a lot of ways tied to whatever it is you're working with in your study there. So our confidence level is 1 minus the alpha. So in this case, we're going to be working with these as decimals, essentially is what that's saying. Your confidence level can also be called your degree of confidence or your confidence coefficient. Generally, we just call it the confidence level in this course. Okay, so like I said, your most common ones are 90, 95, and 99. for the confidence levels and the corresponding alpha that goes with them. If you have a 90%, then that means your alpha would have had to have been 0.10. 95%, your alpha would be 0.05, because basically you're doing 1 minus 0.95, and that's going to give you the alpha. 1 minus 0.99, and that again would give you the alpha here. So those are the three most common ones that you'll see. Okay, it's important that you interpret a confidence interval correctly, and I'm kind of giving you a template here to follow. I don't really want to encourage you to memorize it, but at the same time, sometimes when students try to rewrite it in their own way, they miss the point of it. So the correct way to interpret a confidence interval like this is to say we are a 95% confident that the interval from this value to this value actually does contain the true value of the population proportion P. So the value that's fixed is this population proportion P. We don't know what it is, but it's fixed. And depending on the sample that you gather, the intervals of the confidence interval are going to be slightly different. So we want to write it in such a way that that is clear. Like this is the fixed part, and these are the parts that actually could change. So a lot of times I'll see people write something like there's a 95% chance that the true value of P will fall between these values. Well, that makes it sound like these endpoints are fixed and the value of P is floating around, and that's not the case. Okay, so if you follow this template that we have here and just kind of insert into the red spots, then you're going to have it interpreted correctly. So we are put your percent confidence level, that the interval from put your two endpoints, and then tell what it is that you are estimating. So in this section 7.1, we're talking about proportions, and so therefore it's just going to be the P. Okay, and again, this is kind of talking about the same thing with interpreting it incorrectly. Okay, to do confidence intervals, we have to learn about critical values. So a critical value is the number on the borderline separating the sample statistics that are significantly high or significantly low from those that are not significant. Okay, so we're looking essentially for these values here or here. So in the middle, these are not significant. Out here would be significantly high, and down here would be significantly low. So we're going to learn how to find these cutoff values here. Okay, so the first one we want to look at is the 95% confidence level. So the first thing that we want to do is we want to sketch out our normal curve. And then we're going to take this 95% and we're going to plop it down right in the middle. So this is going to be 95%. Okay, so that leaves me, if I do 1 minus 0.95, then I see that I have 0.05 that's left. And that's going to have to be split between the two tails. So I'm going to have 0.025 here and 0.025 here. Okay, this is going to be my Z alpha over 2 that I want to find. So this is my critical value. Okay, anytime you're finding Z's, you're going to do inverse norm. Okay, we're going to do the area to the left. There's two ways to look at this. We can either add these two values up, and if we add those two values up, we get 0.975. Or we can remember that 0.025 is to the right, which means 1 minus that, or 0.975 is to the left. Okay, so when we do that, we get 1.96. So that's my critical value for a 95% confidence level. This is a very common one, and I would actually encourage you just to memorize this, that for your Z alpha over 2 for 95% is 1.96. Okay, I'd like for you to pause the video and follow the technique that we just looked at and find the critical value for both the 90% and also the 99%, and then check your answers. Okay, for the 90%, we're going to start and we're going to draw it out. Always, always draw these out. So we're going to put the 90% in the middle. So that leaves me with 10%. that I need to split between the two tails. So each tail has 0.05. So this is the critical value that I'm looking for. So I'm going to do inverse norm. The area to the left of this is 0.95. Add these two together. So I'm going to get my critical value is 1.645. Okay, in the past I've said that we always round z-scores to 2 decimal places, and that is true, but I also said there's 2 exceptions, and this is one of our exceptions here. So when you are using a 90% confidence level, the critical value that I would like for you to use is 1.645. Okay, for the 99%, if I draw this out, I've got 0.01. So 0.01 divided by 2 is 0.005. So that's what's in each tail here. So z alpha over 2 is going to be the inverse norm of 0.995, 0, and 1. So the critical value there is going to be 2.575. So this is the second one that I would like for you to go to 3 decimal places on. So every other z value that you work with is going to be 2 decimal places except these two. These are the only 2 exceptions on that, but I do want you to use these 2 values here. Okay, sometimes it's a value that's not as common, like 94%, 92%, 87%, and so forth. You still follow the same technique with this. So I'm going to put my 94% in the middle. So that leaves me with 6% to split. So it'll be 0.03. So my critical value here, I'm going to do the inverse norm of 0.97. 0, and 1, and that gives me 1.88. Okay, so these are the common critical values. If you get 90, 95, and 99%, what happens is you're going to get these so often that you don't want each time to have to go through this whole process. So if you can just remember that for 90% confidence level, you use 1.645. For 95%, you use 1.96, and 99%, you use 2.575. Then I'm okay with you just memorizing these 3 values and not having to repeat that work for it each time. Having said that, if you get something that's not one of those 3, then you do need to still understand the process to get those. Okay, margin of error. The difference between the sample proportion P and the population proportion, the sample proportion P hat and the population proportion P is an error. Okay, and so that maximum likely amount of that error is called our margin of error. Okay, so when we look at the margin of error for proportions, which is what we're working with now, you've got this formula. This formula is located on your formula sheet, so you do not need to memorize this. This is a section that you really need to have your formula sheet in front of you for. Okay, so what we have is we have that critical value that we just got through finding. So if it's say a 95%, then I would substitute for all of this the number 1.96. Okay, then I'm going to put my P hat, my Q hat. Remember, Q hat is simply 1 minus P hat, and then my N is my sample size. Okay, a few things to remember. P is population proportion, P hat is sample proportion, N is your sample size. The capital E is your margin of error. Z alpha over 2 is the critical value, and then also P hat is X over N, and where X is the number of successes and N is the sample size. So sometimes when P hat's not given to you as a percent, you have to find it by doing X over N. Okay, so to do these, for every confidence interval that you do, you need to verify these requirements. The first is that the sample is a simple random sample. So if it is a problem that we're doing, we are going to go ahead and assume that it's a simple random sample. So I'm not going to be asking that you verify this. The second is that the conditions for the binomial distribution are satisfied. Okay, and the main thing there, it needs to be a fixed number of trials. Trials need to be independent. There are two categories, and the probabilities remain constant. The main one is this two categories one. It doesn't mean the others are less important. It just means that's really the main one you need to be checking for. And then here, there are at least 5 successes. So the way we're going to check for this is we're going to multiply n times p hat. That's going to give us our number of successes, and we need to show that that's greater than or equal to 5. And at least 5 failures would be n times q hat, and that needs to be greater than or equal to 5. As long as your sample sizes are large, usually these aren't an issue, but I do expect you to be able to show this. And on this test, I will be looking to see your work. It's not going to be enough just to say yes or no. You're going to have to show your work, and your work will be part of your grade. Okay, so to go ahead and build the confidence interval, what we're going to do is once we've calculated this margin of error, then we're going to go in and add it to the p-hat and construct this confidence interval here. So as far as rounding, we want to round it to 3 significant digits. Okay, so here's an example that I want us to start and go through. So it says we noted that a Gallup poll of 1,487 adults showed that 43% of the respondents have Facebook pages. So we want to determine the type of confidence interval that we're going to be given. So for now, at this point, we're only learning about the proportion type. That would always be our first step once we've learned um, additional types to work with. Okay, the second part is we want to verify our requirements. So we're going to assume it's a simple random sample. Check that one off. We want to be sure that the requirements for the binomial distribution is met. So here, 43% have Facebook pages. So either they do or they don't have Facebook pages. So we're good with that. And then finally, we need to actually show this part. So my n was 1487 and my p hat, this was my n and this is my p hat. So I'll multiply 1487 times 0.43. That gives me 639, and that's definitely greater than or equal to 5. For the n times q hat, that's 1487. My q is 1 minus 0.43. So that's 1487 times 0.57. That's going to be equal to 848, and that's definitely greater than or equal to 5. So we have shown that. So I do need to see these calculations as part of this requirement check. Okay, next we want to find our margin of error. So in this case, we're doing a 95% confidence level. So you either have to go through and find that critical value, or you need to remember that the z that goes with 95% is 1.96. Okay, so that's what's going to go here in this formula, and then we're going to plug everything else in there. So this is 1.96 times the square root of 0.43. Q was 0.57. N is 1487. So we end up with a margin of error on that one that is 0.0252. I would suggest you pausing this video and typing this in and making sure you get this answer, because one thing I see a lot of people do is have it set up correctly and not be able to get this. So double check that you're getting it in there correctly. You may even need to put an extra set of parentheses to make sure that all of this is grouped together underneath that radical. Okay, so we need to construct the confidence interval from this. So for we found that our margin of error is 0.0252. We already know that our p-hat is 0.43. So we're going to plug into the endpoints here. We'll have 0.43 minus 0.0252 is less than 0.43 plus 0.0252. So when we simplify this, this is going to simplify to be 0.405, and this one is going to be 0.455. You could write it as 0.405 comma 0.455. That would also be an acceptable way to write that. Okay, so for our interpretation statement, we'll say we're 95% confident that the interval from 0.405 to 0.455 actually does contain the true value of the population proportion, and this will be of adults who have Facebook pages. Okay, so a follow-up question here, based on these results, can we safely conclude that fewer than 50% of adults have Facebook pages? So if we look back at the interval that we found, okay, this interval is clearly captured well below the 50% mark, and so we could safely conclude that fewer than 50% of adults have Facebook pages. And this was probably old data that we were working with. So that we would be able to conclude that fewer than 50% have Facebook pages. Okay, so on your calculator, I do want to hop over to the calculator and show you how you could do this problem on the calculator. I want to be clear that some problems I will allow that, and other problems on your test you will have to go through all the parts and show me how to calculate your margin of error and so forth. So over on the calculator, I want to show you how to put this in the calculator. So we're going to go to Stat, and we're going to go over to Test. And then we're going to go down to 1 proportion z interval, which is letter A, and press enter. Okay, that's going to bring it up here. So what we're going to do is I'm going to type in the 1487, and I'm going to multiply that by 0.43 and press enter. And so what I want to do is my calculator is going to give me an error if this is not a whole number. So I'm going to go back up and I'm going to actually change it to the whole number that it's closest to. Put in my sample size and my confidence level and then press calculate. And you can see that this actually matches up. If I rounded it to 3 decimal places, it's going to match up to the answers that we just got through calculating. So this is a screen just showing the different calculator screens that you would see to go through the process that we just went through. Okay, going into the next example, here we want to look at finding your p-hat when the x is given. So in the previous problem, the p-hat was given to us, but in this next problem we're going to be looking at, we were going to have to actually find the p-hat. So p-hat is simply x over n. So like here in this example, the drug OxyContin is used to treat pain, but it's dangerous because it's addictive and can be lethal. So in clinical trials, 227 subjects were treated with OxyContin and 52 of them developed nausea. So X is like the number of what we call successes. So if the number of people that actually had the characteristic we're looking for, which is developing nausea, that's going to be the X. And then this is going to be my sample size, or my N. So this is going to be 52 out of 227. So 52 divided by 227 is going to give me 0.229 for my p-hat on that problem. Okay, on this example, we're going to be constructing a confidence interval for p when x is given instead of p-hat. So it says a survey of 1,721 people found that 247 people purchased religious books at a Christian bookstore. Find the 95% confidence interval of the true proportion of people who purchased their religious books at a Christian bookstore. So here my sample size. My sample size is my N, so that's 1721. This is my X, and this is my confidence level here that I'm going to be working with. So the first thing we want to do is determine the type of confidence interval problem, and we do that by looking for our construct or find statement. So here we're asked to find the 95% confidence interval of the true proportion. So we know that this is a proportion type problem. Like I said, that's not that significant in this section because we've only learned one type, but as we move on and add additional types, it's going to be really important that you first identify that. You can always do that by looking for your find or construct statement. Okay, verify that the requirements are met. So we've got a simple random sample. We're going to assume that to be true. The second is that it's binomial. So it is binomial because either they do or they do not buy their religious books at a Christian bookstore. The third one, we want to multiply n times p hat, which is actually our x, okay, because x is the number of successes, so that's going to be 274, and that's greater than or equal to 5. The number of non-successes or the complement to that, we're going to have 1721 times our q hat, which we haven't actually found yet. Our p hat is going to be 274 over 1721, which is 0.159. So q hat is then going to be 1 minus 0.159, which is 0.841. Okay, so this is going to be 1721 times 0.841, and when we multiply that out, we get 1447, and that's clearly greater than or equal to 5. So here on this one, if you didn't recognize that n times p hat was actually going to be x, what you would have done is 1721 times 0.159, and that's going to give you the 274 as well. Okay, so for our margin of error formula is z alpha over 2 times the square root of p hat q hat over n. So this is a 95% confidence interval that we're looking for. So when we're working with 95%, we're going to put in 1.96. That goes back to those critical values that correspond with a given confidence level. Okay, our p hat is 0.159. Our q hat is 0.841, and our n is 1721. Okay, when we do that calculation, we're going to have a margin of error, which is 0.017. Okay, so to find our actual confidence interval, we'll have 0.159, which is the p hat, minus 0.017. This will be 0.159 plus 0.017. So we end up with a confidence interval of 0.142 to 0.176 for the confidence interval. Okay, so for the interpretation, we're 95% confident that the interval from 0.142 to 0.176 actually does contain the true value of the population proportion of people who buy their books, their religious books, from a Christian bookstore. So we always need to tie this back in to what we're actually working with so that we understand the context of what it's saying for us. Okay, so a couple of things to keep in mind when you're talking about polls, as we mentioned earlier, that all this kind of ties into polling. The sample should always be a simple random sample. because if you don't gather your sample appropriately, then it's not going to give you valid results. And the confidence interval, the confidence level should always be provided. And that's not always the case when you look these up on the internet, but it is there, and they may not be reporting it, but there is a confidence level and it really should be provided. Sample size should also be provided. And except in relatively rare cases, the quality of the poll results depend on the sampling method and the size of the sample, but the size of the population is not usually a factor. So just kind of keep those things in mind. One caution, never think that a poll results are unreliable if the sample size is a small percentage of the population, because the population size is usually not a factor in determining the reliability of a poll. So even though it has more to do with the sample size itself than it does the percentage that represents of the population itself. Okay, the last thing I want to look at today is talking about finding your point estimates when you're actually given the confidence interval already. So here we're not trying to find the confidence interval. We've been given a confidence interval. We're working backwards to find your p-hat and your margin of error. So if you need to find p-hat is simply the midpoint of that confidence interval. So what you're going to do is add the two limits together and divide by 2, and that'll give you your p-hat. The margin of error is the difference between those divided by 2. So we'll do the upper minus the lower divided by 2. So you would use that in a situation like this one. Here we have a case. It says there's a statement of the 71 subjects, 70% were abstinent from smoking at 8 weeks, and you have a 95% confidence interval of 58% to 81%. Use that statement to find the point estimate p-hat and the margin of error. So basically they're giving us our confidence interval here. We have 0.58 to 0.81. So if I want to find my p-hat and I've already got the confidence interval provided, what I'm going to do is I'm going to add these two together and I'm going to divide by 2. When I do that, I'm going to get 0.695. So 0.695 is the midpoint of that interval there, and that's my p-hat. For the margin of error, I'm going to subtract the 2. Typically, I like to put the larger one first, and I get 0.115. I say typically because basically our margin of error is usually reported as plus or minus anyway, so it's not terribly important, but it really should be the larger one minus the smaller one. Okay, so that is going to take us to the end of today's lecture. Tomorrow we're going to be talking about sample size and also reviewing some more practice problems of the same material.